A lithography technology called SSMB-EUV has recently created a buzz in China. There are claims that China can build an EUV factory to replace ASML's EUV lithography machines, circumventing US sanctions through an innovative approach. In our previous video, we covered the difficulties of manufacturing advanced lithography machines.
Well, that's going to be the next episode, because we thought it was more important to let you know this first.
For those of you who haven't watched it, EUV system faced many technical hurdles like generating adequate light source power, maintaining optics under high vacuum, and fabricating flawless masks and photoresists. The production of these machines had been monopolized by the Dutch company ASML. Not surprisingly, the limited supply of these desirable tools has become a bottleneck for China's booming microchip industry, especially as US restrictions tighten. To overcome the EUV machine shortage and circumvent the US embargo, China's top minds have been working relentlessly to find solutions. Instead of following ASML's conventional path, they have come up with a different tactic. And that is the SSMB-EUV technology we mentioned before. In a groundbreaking paper published by Nature, Tang Chuanxiang and his team from Tsinghua University in Beijing proposed to build an accelerator the size of a football field to power dozens of EUV lithography machines simultaneously. The accelerator is a ring-shaped device in which electrons circulate at high speed in a storage ring using magnetic fields. Electrons are accelerated to high speeds and sent through alternating magnetic fields. This makes them oscillate and emit short wavelength light. The key innovation is grouping the electrons into nanometer, scale bunches first. Within each bunch, the electrons oscillate in sync. These nanobunches are sent one by one through the magnetic fields, and each bunch oscillate together. They emit powerful coherent light at different positions. These high-energy lights can enable advanced nanoscale manufacturing. This combines two key features, the coherent emission from micro-bunching to generate intense light, and the high repetition rate enabled by the storage ring. This enables the SSMB ring to emit powerful, focused beam over a range of wavelengths from terahertz to soft X-rays in a stable, repetitive way. SSMB-EUV could have huge potential for high-resolution imaging applications of EUV lithography in chip manufacturing. Public interest is driven from hopes of getting around the US blockade, commercializing Tsinhua's research, and boosting domestic chip manufacturing, which has been further encouraged by Huawei's recent 5G chip self-sufficiency. Currently, ASML's most advanced EUV lithography machines use a 20 kilowatts carbon dioxide laser to strike liquid tin droplets, creating a plasma that emits around 350 watts of 13.5 nanometers EUV light. However, this laser-produced plasma technology is capped at 500 watts, which restricts advances in next-generation lithography. In contrast, SSMB-EUV offers several advantages. First, it can accommodate multiple beamlines and produce high average power, driving dozens of lithography machines simultaneously for much higher output. Second, the emitted light is narrow, stable, and precise, which is ideal for imprinting precise patterns on chips. Third, the light output is continuous and consistent, enabling reliable high-volume manufacturing. Fourth, it is a clean source with minimal contaminants that could pollute the chip-making process. And finally, the SSMB principle can potentially be scaled down to even shorter wavelengths in the future, enabling smaller chip features. In essence, the Chinese researchers aim to develop not just a single EUV machine, but an entirely new form of EUV lithography facility for high-volume advanced chip-making manufacturing. Recognizing its importance, China has since invested to construct a scientific facility in Xiong'an dedicated to SSMB research. So, SSMB-EUV is scientifically validated and engineering efforts are underway. But obstacles remain. The performance requirements for lithography machines in industrial production are beyond what most people can imagine. There is still a considerable gap from prototype to production-ready system. The LLP-EUV approach took over 20 years to go from ideas to implementation, so we are looking at years of work. Nevertheless, under pressure from the US, China is being forced to aggressively pursue creative solutions such as SSMB-EUV. With sufficient persistence and resource, breakthroughs may not be so far away. And this could be the game changer if China makes it work.